Git Advanced Techniques. And let's talk about me a little bit, very briefly. I've been a FoxPro developer for a long time. I've been writing articles, a Microsoft MVP back in 2010, and I'm also the co-owner of FoxPert. So if you need any FoxPro experts in Europe, you have found them. So what's this session about? Today, we are talking about Git on working on projects concurrently with different release schedules. So some things should be in the release, some should not be in the release. So it's not about just having one branch, it's about having multiple branches. Also, we talk about how you manage your commit history, besides just checking everything in. And we might have the time to get into some of the fascinating internals of Git. What this session isn't about is everything that Rick had said in his excellent session yesterday, or actually the previous session. So it's not about the UI and all of this. And in true Git history or good tradition, I'm giving you, on some points, I'm giving you the opposite view of what Rick said. So you will end up being more confused than before the conference. So let's start right with the technical stuff. One of the special things about Git is called the index. The index is a directory snapshot that has all files known to Git at a point in time. So if you check out something, there's an index telling you or telling Git what files have been or are in this commit. If you add files to the staging area, Git updates the index and knows about that file. Every file you haven't added is known to Git. And the index contains a list for every file that's known, along with the file name and relative path, the content using a SHA-1 hash value after converting the file to Linux. So for Git, every text file just has a line feed. It doesn't have character return line feed like in Windows, even if your files do have character return. It also has the file timestamp, the size, and in case the current state is a conflict where you have two conflicting versions and a common parent version, then all three versions are in the index, which Git called stages. So you have stage 1, 2, and 3. And there's a lot of other things in there that is specifically for Linux because, well, Git was created on Linux. You can actually look at the index, and you use the ls-file command, files command, and pass in the stage. So these are all the files that are in the repository I'm using. It's a repository that's also in the session material so that you can play with it around. And if you need more details, you can also add the debug switch, which gives detail of everything like the mode, the hash value, the name, as well as the change time and the size. So if you put this into a text file and then have a different commit or different repository, you can actually diff these files and find out what has changed, what files are different. So the index is based on, or Git is based on a three-tree architecture. A tree, in this case, is the files and folders that you're working on. And there are three different ones of them. One is the working folder. That is the folder on your machine, which is managed by Windows or Mac or Linux. So basically the file system. That is your current working state. And then there's the index. The index is what Git knows about the working folder or knows about the current state, and what changes you have told Git to consider for the next operation. And then there's also the directed acyclic graph, which is the technical name. We call it the repository. It's just all the files in there. So for every commit, you have a tree that tells Git what files and what directories existed at that time and what the content is. Whenever you do something or anything with Git, usually these operations compare one of or two of those three trees to determine what to do and what actions they need to perform. So the index is updated in two different ways. One is if you do one of those operations that basically switch where you are, like a checkout or switch, the reset, a merge, including pull. If you do a pull and that has an automatic merge, then Git compares the index that it has with the tree that is being provided by the repository. So if you switch to another branch, Git is looking at what files are in the tree for that branch, for that commit, what files are in your index folder right now, and figures out what files it needs to update and what files it needs to delete. And at the same time, it compares the index with the working folder to figure out what problematic files are in there, files that you have out there that are not committed, that would need to be changed, but Git doesn't allow, or files that would be overwritten because you have a file in there and that shouldn't be in there, that you created new, but there's also a file of the same file name in the commit. So Git is in this case syncing the index, so the index has never been recreated, it's always updated. And then there are some operations like add, restore, and remove that deal with updating the index from the file, from the working folder. So if you add a file to the index, Git is reading the content, adding this adding the content of the file to the repository, and it's adding the hash value and file info to the index. One thing that's important to remember is that the timestamp is always the one from when Git created a file. It's never the one that of the time when you checked in. So every time you check out the same branch, you always get a different file time. And that's necessary because build tools rely on being able to see if the source code is newer than the compiled version. Even FoxPro is doing the same thing. If you have a PRG file which is newer than the FXP file, VFP might compile it if it feels like it. But if the FXP file is newer, it will not get recompiled at all. We typically talk about the index as the staging area and only consider the files that we have added. So if you use source tree, there's a separate area for staging. If you use Tortoise Git, you see the staging area as the kind of the checked or known files. So it's, for most of us, it's pretty short-lived, and we never or often don't consider all files to be part of the index, but the index is actually all files, and the staging area is just the updated part, the files that have been updated in the index since the last checkout or since the last operation that was syncing the index with the repository itself. When you commit in Git, what commit does is it's building a new tree for the repository that compares the previous commits tree and the index tree that we have, and figures out what are the differences, and accordingly creates new tree objects and the commit. So a commit is always a tree. We might have the time to get into the trees a little bit later on. And because the index is never recreated and is used to create commits, any file that you stage persists across switching. So if you have a file in your working folder and you add it to the staging area, you add it to the index, and then switch to a different branch, the file is still in there. So the index is relevant because the index is what Git thinks is what you want to have in the repository. Of course, these files, it's a binary file, can get corrupt, and then you get all kind of weird problems. So if you run into problems where Git is thinking that files don't exist that exist, or if Git is telling you that it can't update a file or anything, you might want to delete the index file and then run git reset, which recreates the index file from the current state of the repository. Any file you have staged at that point, you need to restage. So it's not maintaining the staged state. When you manage, or what you should do is managing the working folder. That's actually something I often see developers not doing. So they have tons of untracked files in there. And instead of adding it to git ignore, which is shared with everyone else, or info exclude, which is just your local copy, they are there and they show up as modified files on disk. And the problem is, if you have hundreds of files showing up as untracked files that you could potentially add, it's very easy to miss the file that you changed. You can never be sure that you have all those files that you need to add, that all the changes you made are actually in the repository. So what I usually do is I try to get a clean state that shows no files at all in my folder. So everything that isn't in the repository and shouldn't go into the repository is either in git ignore or in exclude. The worst case I've seen is people who add a star to git ignore, which tells Git to ignore every single file in your folder, because then you have to remember that you have to add the files explicitly. Git will never tell you that there's a new file over there that you created and that you have to add. So it's in your in your working folder, but it's not necessarily in the repository, and you don't even notice because Git doesn't show anything. Often these developers don't consider this to be a problem because they think they will always remember what they have done since the last checkout and during the day. Problem is that's extra mental load that you should avoid, and it's also a lot of these tools like Visual Studio Code or anything on JetBrains is always adding. It's prompting to add a new file. If you create a file in the tool, it's added to Git automatically. It's added to the index. But as soon as you add a file outside because you copied it from somewhere, or then suddenly it's not on your radar. And that's why you should be careful about what you ignore, and also make sure that you ignore the things that you don't want to look at. So Git has two different concepts. One is branch and one is a tag. So a branch is kind of, well, first of all, there's head. Head is what you are currently working on. And because we are Foxpro developers, I try to translate everything into XSpace. So head is actually the current rec node. That's what you are working on in your working folder. And if you do something and check it in, then head will point to the next commit that you created or to the commit that you moved. Head is always where you are working on. Branches and tags are like aliases, like a table alias. It's a label for commit. Whereas the commit is more like a work area in Foxpro. You need to know the number in order to access this. Or you can give it an alias and use the alias instead of select 5, you do select customers. And that's the same with branches. Branches are very similar to tags, except branches travel with head. If you do something to head and head moves to the next commit, the branch follows along. So the next commit will also have or be that branch. The branch is updated with the commit that you have in head. A tag stays where it is. If you create a tag, that's where the tag will remain. It's linked to a single commit, and it will remain at that commit. When you check out a tag, which is typically done for things like versions, if you have a version that you released, you want to tag it so that you can recreate that version. And you commit something, you create, or you are in a situation that you have a detached head. A detached head means that you don't have a branch that is associated with the head. In Git, commits need to be found somehow, and there need to be a reference to that. And branches are a reference, tags are a reference. But if you don't have another reference, then you would need to know the commit hash value. We get into that in more detail later on. Branches also have the ability to track remote branches. So you can say one branch is tracking a branch that originates from a remote. It's still in your repository, and updating the remote will automatically update your local remote branches. Local remote sounds a little strange, but that's basically what Git is doing. Any questions so far?
Just one. Why would one choose git ignore over info exclude?
When would I use git ignore over exclude? Git ignore is the files and contains the files that everyone has. That should not be in the repository for everyone. So I have 2 git ignore files that are on GitHub, which excludes, for instance, all backup files, all compiled files, FXP files, all error files. Exclude, on the other hand, is for the files that you create yourself that are not necessarily the same ones as the other ones. Like if you have a backup of your data folder, data_old, data_old2, copy2 or something, then you don't want to add this to git ignore because nobody else has a backup folder of that name, and it might not even live long on your system. So anything that you created in there that is not part of the repository, but you need it to work or as a backup or whatever, that goes into the exclude file. Okay. Git has that's actually the git ignore file. So there's one for single and one for team, and which you can download. So it's excluding different things depending on how you work. So there's 2 different team workflows. A lot of people are actually using the single, where you have all the binaries included and have maybe the exe included. Whereas if you work as a team, you don't want to have those included. So that's a team workflow. And this is a default file that you can download and then use as your git ignore file for any VFP projects, excluding all these files that we typically that happen, like the stumps.db and the desktop ini file, but that we don't need, that we don't want to have in the repository. So the 2 workflows are team versus a single developer. If in this session I'm talking a lot about team development, so it doesn't necessarily mean that you work on this on a project with multiple developers. It could be you that is working on different things that need to be ready at different times. So you work on a major rebuild or redesign of your application, but at the same time you have to provide fixes and provide updates for your application. So you don't want to have all the new stuff being shipped in the old application. So you somehow need to switch between the 2. And if you work as a team, and as I said, it could be just you working on different modules, you need to avoid a couple of things. First of all, you really have to avoid binary files. Binary files cannot be merged. So if you change something in 2 branches, you need to deal with the binary files. Some binary files are okay because they typically don't change frequently, like images or icons. But any binary file, like a copy of a database or the Foxpro files, they don't belong there. It also means that if you have configuration files, even if you use DBF files, the repository should only contain a text file, because that's the only thing that Git can merge. You will always need to be able to merge. You also should avoid duplication. If you have a text representation of the SCX file, and either SCX XML or in SCA files or SC2 files, then you should not add the SCX just in case you cannot convert it back. But because yes, it's adding extra security, but it's also adding a lot of overhead if you ever have a merge conflict, and you might end up producing another binary that is not matching the text file. Other things that do not belong into a repository is the release files. So not the exe, not the DLL, not anything that you created. Only the source files and only as text files. Branches are actually great for applications like Foxpro, Foxpro applications, which tend to be very monolithic, really big applications having hundreds of features all in one exe. Whereas modern applications typically tend to be spread across several services, several microservices, across different servers. So you can change one little piece at a time, whereas in Foxpro, you have to change a lot of things. If you add a new feature, you're going to touch not only a form, you're usually going to touch database structures, classes, programs. You have to make changes to the menu. And branches make it possible so that you can change things without affecting your shipping product right away. All tools, and even people who are using the command line, often use a graphic representation of what the task what a branch looks like. So I'm getting behind time. So most of the tools you see use colored lines, and it's very easy to think that task 1, which is the branch that starts here, is the red line. If this is branch 1, that's what it looks like, but that's not what it actually is. If you look at branch task 1, this is branch task 1. That's the commits that are part of the branch. Commits are like a family. You have 1 or 2 parents, any number of children, and a lot of baggage that is attached. So a branch just points to a commit, and a commit always comes with every single commit that it inherited right from the beginning. So if you merge task 1 into something, you merge all of these commits, not just the line. And that's why it's easy to make mistakes, or what I've seen in several developers. Some, for instance, fear that they can't delete a branch because they don't know what happens with commits. But deleting a branch is just removing a label. And as long as that commit is reachable through some label, even if it's after it's been merged, is the main label or the main branch, the commit isn't going away. Of course, you should know when to delete a branch. We get to that a little bit later. Also, merging a branch. Sometimes especially if you think of a branch of just those commits in the same color, you think like merging just adds those, but merging is all or nothing. You cannot merge some features. You always merge the entire branch and make it part of the other branch. So there's not a lot of control over that. It's the branch or it's not the branch. There are other ways that we talk about alternatives to merging that we talk about in a minute. So when you work with branches, there are a couple of common issues. So let's look at the repository and we have 2 commits here. They are both derived from the same task 2 commit, the first commit on task 2, and April did one and June did one. So what April was adding is, if you look at the differences, is it's doing the adding magic. It's actually magic is Fox. It's adding not magic. It's adding reverse magic, pocus hocus. Whereas June was adding forward-facing magic. It's adding abracadabra, returning magic. So what happens if we are now currently in main, and we want to merge those two? Because they are on the same tasks, it's just 2 different developers, so we want to merge those. So we merge the first one into main, merge to main, and that's no problem. And then we go back, that's the one, April's, and then we go in and try to merge June's. And now we get a merge conflict. Why is that? The problem is Git doesn't know anything about the structure of the file. Git is always using changed lines. And in this case, we both added the procedure at the end. So it's the last line of the PRG file had been changed. So what you want to do in files where you don't have a natural order in the files is, go back. Is to that is to make sure that you in some way sort these files. So what we did for procedure files, for instance, is check out is one moment, is to sort these functions alphabetically. So instead of just adding at the end, we made sure that we had them organized by alphabetic order. You could also do it by group things by topic. Anything is better than just adding files at the end, because the end is always the one that causes a conflict when you check it in. So if I go back now and commit this one, nope, no, nah, okay, get it over here. Let's get a log. You know, I'm just doing this from the cloud. Wrong. Clearly. Slow down, Christoph. Slow down. Okay. So now this one. We have a change that is not based on over here. So we go back to main. Let's check out to main, and then we can actually merge this one. Merge to main. And there's no conflict because we did change 2 different positions. Similarly, when you switch branches, FXP files can be a problem. It's not that, and as long as you have set development set to on, Foxpro will recompile PLG files if they are outdated compared to the FXP files if they are outdated compared to the PLG file. The problem is if you have a new file in one branch that creates an FXP file, then switch to another branch that doesn't have the PLG file. The PLG file is removed, the FXP file stays. But if you use any of the features inside that FXP file, Foxpro can't find the PLG file, but it can find the FXP file, and it will just happily use the FXP file, even add it to the project instead of the PLG file if you build the project. So you might end up using features that are actually not in that branch because you have the FXP file lying around. Also, stale branches, it's when you have a branch that is supposed to be short-lived, but for reasons it is already months old, then you often have problems that there's a lot of conflicts with the latest version. So you need to make sure that you maintain branches and that you delete branches that have been merged and accepted, so that you actually know what kind of branches you have locally. One big problem of branches is, if you have multiple branches, is refactoring. If you do anything where you need to go through the project to update things, what you usually do is you search the project, and if you rename a method or a procedure, you just update all the references that you find. If you add a parameter or if you add a field or anything, you just go through the code and edit all of that. Problem is, if you have a branch that is not the one that you're working on that also has changes, you don't see this code at that moment. You only see this code if you switch to the branch. So you might have changes, or you might do changes in your current branch that would need to be done in the other branch as well. But because the code is not visible to you, and you might even not know what's in the other branch, you don't see it. So this is one of the things where refactoring might require that you coordinate things a little bit more than you usually would do. It's usually safe to do factoring within a method or within a class in methods that's private or protected methods, but everything that requires changes outside of that scope is something where you need to coordinate. When you work with branches, there are two ways how you can work with branches. One is you have one folder, that's your working folder, and every time you switch branches, you do a git switch or git checkout. So if you work on one ticket, you check out to that ticket, then you commit. And if you work on another ticket, you switch to that ticket branch and keep working on that. The other option would be to have multiple copies of your project. So instead of switching within one working folder, you just make multiple copies of your project. And every folder is set to a fixed branch that you work on. So if you work on a different ticket, you go to a different directory and open the other project file and work on that. This allows for quicker task changing because you don't have to commit or stash, and you can just go to the other folder, even keep Foxpro open and look at both versions of both branches at the same time. And if you leave things sitting there and then come back weeks later, you have the folder in this position where you last worked on that project. It does require some work on the application, though, because you must have something that you can pull from the repository and do minimal extra effort to make it work. So the data must be ready, and if you don't have the data, you probably don't have the data in the repository, so you either have something that you can unzip quickly, or your data is somewhere else where it can be used. You also have to make sure that you don't have any global configuration registry setting that point to the dev folder, assuming that there's only one dev folder, and also no global services that you need to update. It does prevent mistakes that exist because you created artifacts in one branch and then switch to another one where those are interfering. But it also adds another layer of complexity. For instance, IntelliSense shows you the most recently used files, and it will show you the different project files all have the same name, but they are in different folders. And if you can't see the folder name, you might pick the wrong one, and suddenly you are in one branch and opening a file from a different branch. So it's you need to figure out what is working for you the best. For this approach, actually, there's something that's in Windows for like 2 years. Not everyone has heard about that. That's the development drive. The development drive is using the resilient file system, which has been available on Microsoft Server systems since Microsoft Server 2016. And one of those features, aside from more stability, is the ability of deduplication. On the desktop systems, you hardly could use resilient FS. Sometimes some features were available. For a short time, you were able to create a volume. Now you can only mount a volume. But Microsoft offered resilient FS in terms of the development drive, which is something you can create by going to Settings, and then you go to System, Advanced, and then down there is Dev Drive. And I've created one here. You can create other ones. You can either create a dev drive as a partition on your hard disk, or you can use a virtual disk and create a virtual disk that is formatted in resilient FS and then mount it as a drive or mount it into a folder. So what's the advantage for this approach? One thing is the development drive is considered by Windows as secure. So it does have fewer security checks. It's excluded by virus scanners, at least by Microsoft Defender. And also any security check that Windows performs, it's not performing it synchronously, it's performing that in parallel. So when you have a file that needs to be scanned on a regular drive, you have to wait until Windows decides, okay, that file is good. On a development drive, because it's considered to be secure by default, you are allowed to work on this, and parallel, Windows is scanning the file, doing whatever it needs to do, assuming that usually there's no problem, and if there's a problem, well, then you get notified, but you can still work at that time. The other advantage is the deduplication. So we'll look at one. I have a development drive over here, and I look at the properties. So we see what's used, and you see I have 1.45 gigabyte used. So now I'm going to copy a large file. No, it's not that large. So now I have 1.54 gigabyte used. And then I'm going into Explorer and copying this file. And I'll just make a couple of copies. So you see it's now 1 gigabyte of files that I've created. If I go here, you see that I still have 1.54 gigabyte, because what Windows did was it just created a new directory entry for all these copies, but the content of the file is all the same. It's all pointing to the same location on disk until you make a change to that file. And at that point, the block, just a single block, the cluster that you changed is updated. It's called a copy on write. Every time you write to this file, you're writing it to a copy, and at that time, the space is actually used. So what this allows you to do is to have a copy of your main branch repository, and then just copy that folder for a new task, and then check out to the new the task that you're working on, so that you don't actually create a lot of copies that are taking space. You don't have tens of duplicates of your repository. It's just one copy, and then the changes, which tend to be very minor. Another thing that Microsoft is adding right now for Git support is, where's my slide? Oh wait, no, it's not my slide. My slide is here. Is Explorer integration. It's currently only available, I think, in Insider and Better builds, and not in all of those. It's some feature that needs to be somehow, activated. And it in System Advanced File Explorer setting, you can enable and specify which folders are repositories. You have to list every single folder that is a repository. And if you do this, you have the option to show like last commit messages and the state, modified, added, untracked, and view this directly in Explorer. So it's basically like Tortoise Git, except it's native to Windows. Any questions?
Not right now.
Okay, cool. So when you merge or sync branches, there are 3 ways this can happen. One is called a fast forward. So every time everything from one branch is already in the other branch, all Git is doing is moving the head. So that happens, for instance, if you were working on a branch, someone else is working on the branch, somebody else checked in all kind of stuff, and you didn't do anything. So in this case, your head is just moves to the head that the other one created. Same if you created a branch from main, did work on and created a few commits and want to merge this back to main, but nobody else did any work on main, then the head of main is still the original from your branch. So your branch becomes the new main. Main is just moved to your branch. That's a very fast operation because it doesn't involve creating any new commits. It's just updating wherever the branch is pointing at. A merge commit is something that what you usually see. If you work, if you've followed along the examples in all these Git sessions that we have seen, most recently yesterday from Rick, but also Doug and I think Tony had sessions, you usually merge a branch into another. So you merge your task branch or your feature branch into main. There is another way in Git, which is called a rebase. And a rebase means that it's rewriting the history of your branch as if you started it after the other. So you started early, did some work, but rebase is pretending that you just started these things and adds your branch after the other. Rewriting history is something that there are different views. If you look at corporate tools, you find that history is very important because the repository tells you who did what, when, and why. And it's something that shouldn't change. It's like accounting. That's an unmodified version. It can be used by all departments, including human resources. If you need to find a reason to get rid of someone, you can look at the history of what they did and find something. If you prepare merger with another company, you want to know how the IP has been developed, the intellectual property, and who has been in contact with that, who knew about these things. Same on the other side, if you want to find violations, you can use the history to find these things. So it's for companies, it's usually important to know exactly what happened at what time and why. The same thing isn't true for open source. So open source has a completely different view on the history. The repository is just the current state of development. That's what we are working. That's what we currently have. And the history they have is to make reviews easier. In Linux, it's considered that more people review a commit than create one, because every commit that you create has to be reviewed by several people before it can be merged into the master repository, main repository. The history is used to locate bugs very quickly. It's also because in Git, every commit is based on the previous commit and is basically cryptographically chained. You cannot just change a commit in the path being noticed. So the integrity is very important for open source projects. And other than that, they just don't want to get the history in the way of working. So rewriting history is something that is very common in open source, but it's not very typical for corporations. And if you look at systems that Microsoft created, like SourceSafe or TFS, changing the history in the past, that's not something that's in there. If you wanted to undo a commit in SourceSafe, you had to create a commit that would do the inverse of what the commit did. So you would basically edit the file again to make it look like the commit before that. And all of that remains. And if you look at enterprise versions, most often the features that you find is that there's more logging, more access control, more of everything that's relevant for a big company, but very rarely it's really the features. So rebasing a branch, what's that? Let's assume you have a branch main that has 3 commits, and you worked on a topic branch, a feature branch, a branching of E. So you created commits ABC. What rebase is doing, it's replaying the commits ABC based on G, for instance. So it's instead of working your way from E, you pretend you started at G, and then all the changes you did are based on that. Even if the changes are the same in every commit, it doesn't have the same parent, so it's not the same commit, so the hash value changes. So that's why we, in standards, you often find it as A prime. It's another commit. It's not the same commit, but it has the same content from a developer's perspective. So why would he do that? It avoids overly complex branch structures. If you merge between different people and different branches, keep merging the main branch into your branch, so you have like 5 commits that are just merges from main and 10 commits that you wrote. This allows you to make a cleaner history that is more linear than it actually was at the time you created it. Also, if you do it early enough and rebase frequently, you avoid merge conflicts, because otherwise, every time, if you have a merge conflict in one commit, every time you merge a branch that started at the commit before that, and with a branch that is in a commit that is in a branch after that, you have the same merge conflict, and you might have to solve the same merge conflict several times. So let's look at what rebasing. Let's look at some examples of what you could do. So you might have started a new feature branch, and then after you've done some work and you've added a few commits, you realized you branched off another feature branch that you were working on previously. You didn't do it on main or development or whatever your main branch is that you're supposed to branch off. So you kind of need to move your work to main because you were on the wrong branch. Or maybe you had something that another branch had something that you needed because that's a feature and you needed to extend on that feature. So you started your work on that other branch. But in the meantime, the part that you needed has been merged into main or into development. So you could now, if you would start now, you would start off main. So you can move your commits over there. And sometimes what happens is you add something like a password file, and you realize that wasn't a good idea. But you have done new commits, so you kind of need to remove that commit. So you want to rebase the commits after that onto the commit before that, so that you can get rid of the commit and everything that follows it, but still have everything that you did after that. So any question about rebasing, what it is? I assume no. So let's start. Let's look at let's look at the steps. So for this, we look at the repository again. And we have branches here. We have a task1 branch. And let's assume we want to pretend this task1 branch is actually on top of main. So what we do is we go to the terminal, we check out the task1 branch, and then we do a git rebase main, telling Git to make task1 appear as if it was created in main. What you see is that what's happening is Git is going through all commits, finding the oldest commit that is not yet in main, and then it's going commit by commit. It's replaying, it's adding a new commit that has the same changes. The problem is, if you had a conflict, you will have the conflict every single time. So now we have a new commit that Git created over here. So this is what main was here, and we already added 3, but for the working tree, the 4th, we have a conflict because we have changes in at the end. So we changed the same line with 2 different things. So let's use this text block from the right before the left and call this resolved. And when we do this, we have to continue rebasing. So right now, Git changed 4 commits. We use git rebase continue, and we'll add the next one. So we get a commit message, that's vim. So you press escape, you press the colon, and it's WQ for writing and quitting. And you see that we now have another conflict. And as you can tell from the Git comments, if you have to create a commit history from scratch, you kind of need inspiration. So you can tell I was listening to Alan Sherman at that time. So basically, if you have a conflict, you will have a conflict all the time. All the other commits up to the 9th day of Christmas here will have a conflict. So you don't want to do this right now. So let's just abort the rebase here and let's try something else. Abort does revert everything that's been changed. So we are back in main, a main branch. Branch task1 is still where it was. So let's do something else. Let's take task3 and base it on task1. So we check out to task3 and then say rebase, git rebase task1. And it successfully updated. Yeah, no problem. We look at what happened and we see, well, nothing really. And that's because Git is very polite. It's whenever you give it a task that's technically possible, it's not going to say something like, I'm sorry, Dave, I'm afraid I can't do this. No, it's not. It's telling you, yeah, doesn't make sense what you're asking for, but it's possible. So yeah, I'm going to do it. And in this case, I was asking Git to get all the commits that are not in task1 but are in task3 and put them ahead of task1, but I already merged task3 into task1. So there were no commits, but Git isn't complaining. So let's try this one more time. We reset task3 to the one that we doing a hard reset. So task3 is now back there. And we also remove the merge that we created. So we check out task1. You can do all of this in the command line, but I'm thinking it might be more visible doing this in Git. So I reset task1 to the commit before the merge, also doing hard reset. So now, if I hit F5, now we have task1 that is not merged, and we have task 3 over here. And now we can actually rebase these. So let's go in here. We are on task 1. We want to be on task 3, because that's the one that we want to move. And then we say git rebase task 1, moving everything from task 3 on top of task 1. So if we refresh, we see now that here's task 3, it's the latest one, and this is task 1, and everything in task 3 has been added on top. And the former commits that have been down here somewhere, they disappeared. So now we have something that looks like has the same changes, but it looks like I've did it, well, the commits actually keep the date, so you can see who did it, but they are not in chronological order anymore. It looks like I started task 3 after I finished task 1, but that wasn't the case originally. Nope. So important is that we have other commits now, and if you push this to remote, you might encounter problems. So rebasing branches is an advanced feature. That's why it's not being used that much so far, or especially for beginners, because you can also rebase any commit onto every other commit, do whatever you want. You can completely restructure the repository, but it doesn't have to make any sense. So initially, if you want to make sure that your repository looks the same, what you want is you want to make a copy of the repository, and then in this case, I was comparing the task 1 repository that has task 3 merged, and now I'm rebasing task 3 onto task 1, so the resulting repository should have the same content. If it doesn't, then something went wrong. If you have conflicts, everything, because commits are replayed commit by commit, every time you have had a conflict that you solved, you will have the conflict again and again and again. Commits that were replaced or moved, they are still in the repository, but they are unreachable. So nobody can base their work on that. So as a rule of thumb is you only rebase what's only in your repository. Anything that's known to the team, anything you have pushed already, that's not something you can rebase. And that brings me to another topic that people like to, or developers like to use repository as kind of a backup. So you commit frequently, so you can go back to a working version, and then you push frequently. Rick said it, in case of fire, commit, push, exit the building. So even if the hardware breaks, work is safe. The problem is there's actually 2 different kinds of repositories you can push to. A commit is something that only affects you because it happens on your local machine. But if you push to a repository that is only your repository, nothing happens because nobody else would base their work on your repository. But if you work on a shared repository, then what you push affects others. In terms of you often see this as fork versus a branch. Bitbucket, for instance, encourages you to clone a repository and then create a branch for your development, whereas GitHub encourages you to fork a repository, so create your own repository and then work in that repository and create a pull request that is where the flow is from one GitHub repository to another GitHub repository versus from your local development branch to the remote development branch. This is also where there are two names that are very similar. There's origin and there's upstream. Originally is a clone of your own repository. If you have a repository somewhere and you make a clone for your work, that's origin. Upstream is the repository that someone else owns. You make a fork of someone else's repository, so that is upstream. into your original repository and then create a clone of your original repository for your working folder. That was the original intent of what Linus Torvald did on the Linux repositories. But over time, things like branch permissions, repository permissions have been added. So there's kind of a blurry distinction between forking and branching, even though it's a completely different approach. So when you decide when to push, you actually have to consider, is it a private working repository that you own? Then you can push. Is it a local bare-bone backup repository? Because that's one thing you can do. You can just create a repository on your disk or in your private account and then clone it to that and then clone from that. Or is it a sort of truth main repository where everyone is working on? In this case, you don't want to push unless you are sure that what you push is the thing that everyone else should see. So it's more like commit often, clean up later, push once. Branch is GitLab and Bitbucket are both branch-based. They use one repository and everyone is doing that and creates a branch to get do their work, whereas GitHub is fork-based. You make a copy of your repository and work in the copy. Let's skip that. What you see is that, and originally there was Git. There was a Git client, that was the command line, and there was a web front end there where you could see the history. But that's the system, basically. And then we got GitHub, Bitbucket, and all of these services. And what these services has introduced is pull requests working on the repository itself. So what you see today, nowadays, often is that developers keep adding commits. And when they are finished doing something, they create a pull or merge request, depending on the tool, what's called. And you get something that has two views. There's a commit view, and there's a changed file view. And everyone I know goes straight to the changed file. The commits don't care. You don't care about the commits. You might have added something and removed it later in another commit. Nobody looks at commits. Everyone looks at the changes of the file, and if that looks good, they just merge this branch, which maintains all commits because that's based or created for companies, and companies value an accurate history of who did what. The original case of Linux was there's a clear separation between a private repository and the upstream repository that Linus Torvald and others maintained. In fact, Linux is now on GitHub, and there's over 1,000 pull requests, and every single one of them has a reply that says, you cannot make a pull request on the Linux repository. Please use the mailing list. Because what Linux is doing is you create your private repository, you fork the repository, you create the commits. In your repository, you want to know what you did because you want to be able to get back. So you want to have many commits. The upstream repository, Linus, he doesn't care about what you did to get what you did wrong. He just wants to have basically one commit for every single change and not more than 15 commits if you have a patch set. And for every single commit, you have to send a patch to the mailing list for it to be reviewed independently and at the end being added to the repository. That's why the Linux repository, even though it's a giant project, only has 1.9 million commits. It probably during development has like 100 times of that. But they don't want your history. They just want the result. And that's why we have a lot of features that we are not using, like scrolling, rebasing, and bisect. So I'm getting to the end of the session, so we don't go into the details unless we move daylight saving time a couple of days ahead and turn our clocks 1 hour back. Then I have 1 hour more. So let's do one more thing. That's bisect. The idea is, or the goal is that we want to find a commit that introduced the bug. Oh, are there any questions so far that I should answer right now?
Yeah, I'm sorry about the last time. I accidentally hit the back button on my mouse and I was not backstage. The question that we have from Joel is, I never delete feature branches because I don't want to lose any commit history. Does merge commit always retain full history as long as you don't squash or flatten the commits, or are there rules for this? Could I safely delete feature branches without losing history?
You can safely delete feature branches. The branch, because it's a tag, once the feature branch is merged into the final repository it needs to be merged into. So it's merged into, if it's merged into main on your repository, and then you make a pull request on a remote repository, and then it's merged on the remote repository, then you can safely delete it, because because every commit already belongs to another branch, to main. You lose commits when there's no branch, no tag, or nothing pointing at that commit. At that time, the commit is still there in your local repository, but it's unreachable. It's called an unreachable commit or unreachable object. And eventually it gets removed by garbage collection. On GitHub, you cannot actually get to any unreachable objects, so it's gone. So as soon as a commit is being merged into another branch, you can delete the old branch. No
That's
questions?
all.
Okay, good. So bisect. Bisect is a technique to find a bug. So we get a report that something is not working. We want to find out the commit that introduced the bug. So what we need clean commits, we need testable code. And what bisect does is it's performing a binary search on commits to help you to identify the one that is buggy. So the first thing you need to do is to reproduce things. So you can use Fox unit for this, but from my case, I'm just creating a program test, and this program calls a method in main apparently. So, and I make sure I'm on main. I run this test program, and you see the result is a set of asterisks. That's the wrong result. Now we go into, let's go here. So we need to locate a buggy commit. So we have a commit that is buggy. It's the latest commit in main. It could be a commit for the version that has been tagged that the user's running if we have an older release version. And the next thing is we need to locate a commit where the bug is not present. It could be just the first commit in your repository because you're using a binary search. That's still quick. Let's look at this repository history. And if you go back, well, before we did any branching, that's probably a good thing. So let's check out this branch. It's now creating a detached head. There's no branch in here. So we have, Tortoise Git creates a branch because otherwise we might shoot ourselves in the foot, but Git itself would not create a branch. So we run our test program again, and this time we get a number. So there clearly is a change anywhere between the first and this commit, anywhere between this and main. So let's use bisect for this. What you do is we start bisect. That's starting a special mode. Now Git is waiting for you to tell which commits are good and which are bad. So the one that we are currently on is the one that is a good commit because it's the working commit. So this one is good. Then we switch back to main, which we tested, and tell Git that is a bad commit, Git bisect bad. So we will probably need 4 steps. And because it's all working on the same repository, all compatible, we can actually look at Tortoise Git to visualize this. So we have a bad commit over here, which is the top of main. We have a good commit over here, which is the one that we tested. And we are now right in the middle of those. We are checked out in the middle. What we do is now, you would now generate the binary files or whatever you need. In this case, it's just PLG, so I can execute this. It's still bad. The error is in here, so we tell git bisect bad. Now it moved, this one is bad, so it moved to this one. Let's test this one. Git is asking us. So we do, this one is good. So we tell git bisect good. So now we are here. And it's moving down because we have multiple branches. It's not just going in out of time. It's trying to figure out what is in the middle. So we have this branch. Again, we check. This one is good too. Well, actually, just go up, git bisect good. And now we are in another. We test. This one is bad. And we found it. This one, C9BB, the commit message being April complained that I wrote to the wrong branch, just trying to set up my own branch here. This contains a change. And if you look at the code, yeah, hard to see probably. This was 68,400 minus seconds, which is the remaining seconds of the day, and it's changed to seconds minus seconds, which most of the time results in null, as 0. So it's causing the problem. So it took us very few attempts to actually get to the commit that caused the error. And now we can understand what happened. We can look at why did May change this, and we see that it's actually probably an unexperienced developer who tried to do something and then tried to delete it, but actually merged it into main, and then did some other things like finished the created things on using a VFP3 book, which is kind of outdated, and then, yeah, got a new control class, and at some point, probably a review. Because what you want to do is you want to know why this, you don't only want to know what the error is, you also want to know why it's in there. Because the assumption is every time you put something into the repository, you have an intention. And there's a reason for that. And the reason might be that you wanted to fix something, and this is just a side effect of fixing it. So if you remove it, you will have the old behavior, the old buggy behavior again. So you need to find a different solution. Or like in this case, it's just a training issue, and you discovered some needs of training and some commits that you might need to take care of. So that's bisect. Well, we are kind of running out of time, so let's go through the final things very quickly. Stashing and popping. Whenever you have made changes and you need to merge, switch, or do anything that changes your working folder, those files that you have modified might be in the way, and you can either commit them so they become part of the repository, but sometimes the changes you do is like adding debug code, changing a config file, deleting files just for testing. You have a state that you want to preserve because that's what you need for testing, but it's not a state that you want to have in the repository. So what you can do is git stash, which creates a temporary commit of everything in your working folder and removes everything from the working folder, resets it to a clean state. Then you can do something like perform a merge and then do a git stash pop, and all the changes are reapplied to your new working folder. Cherry picking is when you need something from one commit, like I have a task 5 that has something that's useful. This is a useful commit that I need, but it also has another commit that added a ton of code into the commit. So if I would merge task 5 into my own branch, I would get this commit and this commit, but I only need this commit. So what I can do is, let's assume I'm on main, check out main. I can say I want to cherry pick this one. This is cherry pick this commit. This takes this commit and reapplies the changes that this commit has onto main if there's no conflict. If there's a conflict, you need to solve this conflict, and that's because, well, I made a lot of changes. So let's just put this text before that and this text before right before left. Let's just remove those. Yeah, that's fine. That's resolved. Close. Commit. Ignore. Done. And then you have the same commit that you have here is now also on main. This is a useful change. This is just the change that we did in the other commit, except it's applied onto main. And I just noticed we have still the good and bad things up here. That's because I didn't finish the rebase git, rebase, reset. That's when we, no, git, now we git bisect, rebase, bisect, reset that finishes the bisect operation. So that's, unfortunately, that's all. I can tell you more in the Q&A. So all the other things, well, yeah. A lot of interesting topics. So what we learned today is organizing your work in branches and forks, rewriting the history. We didn't get to the understanding of the Git folder except for the Git exclude. So thank you very much. And please fill out the evaluations. They are very useful for every one of us. So I'm heading over to the Q&A. Thanks again.